about quadratics. Okay? Now, what are quadratics? Anyone know what quadratics are? What shape do they have? How are they different than other functions? Okay, let's start with linear. What's linear? What would be the shape of a linear function?
A straight line.
Straight line. Okay? So a linear function is a straight line. Perfect. Now, how about quadratic? What would the shape of quadratic? Do you know how it might look like?
Crossing over another.
Sorry, too many people talking at the same time. Put your hand up.
One
Carlos?
crossing over.
Carlos? Like a U shape? Like this, you mean? Have you seen shapes like this? Parabolas, they're called parabolas. Have you heard of that word before? Parabola? Okay. Have you seen in real life, have you seen shapes that look like this? Yeah? Arches. Have you seen the McDonald's sign? What's the McDonald's sign? It's actually two of these next to each other, right? Right? Have you seen a basketball player play? How would the ball go? Right? Perfect. Parabola, otherwise it won't go in. So all of these are examples of quadratics. Okay? So quadratics, they're a type of function. Okay? We have the linear, which is a straight line, which we see that things are going constantly up every single time, right? So if let's say I have a straight line, okay, we see that you're going to go up and go over, go up and go over, go up and go over, and it's a constant going up and going over. It's the same constant slope, right? So that means my difference is always the same, okay? With quadratic, we don't see that. With quadratic, we see an increase, and then it kind of flattens out, and then decrease. Or we see a decrease, and then flattens out, and then increase. Okay? So they're different, way different than the linear. Okay? For linear, their degree, or if I'm writing the equation, we talked a little bit about this on Monday, right? And then we looked at equation that looks like this, for example, right? And the degree here is 1. We don't see that because it's a degree 1. We don't see any number on top of the x, right? With quadratic, what do you think the degree is going to be? 2. So when I look at an equation for the quadratic, we're going to talk more about this. But when I'm looking at an equation for quadratic, I'm going to see something like this. Right? Where I have an extra term that has an x and a 2 on top. That's why it's called quadratic. Right? To the power of 2. Okay? So these are a new kind of function that we're gonna learn in grade 11. Okay? When it comes to quadratic, we talked about linear on Monday, and we said there's 2 ways that we can write linear, right? We can write either this way, or if you guys remember the ax plus by plus c equals 0, right? Where everything is on one side. Okay? So there's 2 ways that you can write linear. With quadratic, we have 3 different ways that we can express quadratics. We're going to talk about all these 3 different ways. We're going to talk about how can I go from one way to the other. Okay? We're going to talk about why do we need all 3 different ways. Okay? Why not one and move on with our life? Okay? Because each form is going to give us specific information. papers on the wall. It says standard form, vertex form, and factored form. We're gonna focus in the first unit on the vertex form, that green sign. Okay? So we're gonna focus on that, and then we'll talk about factored form in the next unit. Yeah, factored would be next unit. Okay, so we're gonna start our lesson with modeling quadratics. So how do I know that I have a quadratic function? Now you know the shape of a quadratic, right? We just talked about the shape, right? The arc. Yeah. So it's going to be either opening downward, or we're going to look at the opening upward as well. Okay. Now let's see the difference here. So I have three different formats for each question. So I have the equation, I have the table of values, and I have a graph. Okay. So let's look at the first scenario. The first scenario says the distance traveled by a boy on a bike is modeled by the equation y equals 3x. Okay? So if you look at this specific equation, by looking at it, can you tell me if this is linear or quadratic? Linear. And why is it linear? We don't have the square, right? So if it's quadratic, the square, the degree will be 2. In this case, the degree is 1. So we know that this is linear by looking at the equation, because it's degree 1, right? So I have a invisible 1 that goes on the x. So I've given you a table of value here, okay? And the table of value has the following. So the first one is filled out. We're going to fill out the next. So if I give you the values for x, remember we did that on Monday, right? I gave you values for x, you plug them into the equation, and then you find the y, so you can graph. You remember that? Okay. So we have the same scenario here. I have the x values, 0, 1, 2, 3, and 4. And then if I plug in the x into my equation, I get 3 times 0, which is 0. Then if I plug in 1, I get 3 times 1, which is 3. If x is 2, 3 times 2 is 6. X is 3, 3 times 3 is 9. X is 4, 3 times 4 is 12. Okay? So up to this point, we've seen this on Monday. Okay? Now, if I'm given a table of value, or if I have a table of value, or if I find a table of value, from the table of value, I can figure out if it's linear or not. Okay? And here's the process. I have to do what we call the first difference. Okay? Now, what does the word difference mean in math? What operation when I do difference? Subtraction. Subtraction. Okay? So I have to do the first difference. So I have to subtract the y values. Okay? So look at this. I have the y values here. Okay? I take my y value, I start from the bottom, and I subtract the bottom from the top. So I subtract the top from the bottom. So I do 3, take away 0. Okay? So I do 3, take away 0, and that gives me 3. Okay? Now, I go to the next one, and I do 6, take away 3. So you always do the bottom minus the top. If I do 6, take away 3, I get 3 again. Then, bottom minus the top. 9, take away 6. 3. 12, take away 9. 3. What do you notice here? That all of the differences are the same, right? So I do my first difference, and I find that all of the differences are exactly the same. Do you think that's a coincidence? Is it always going to happen if I have a linear function? Yes. Okay, we're going to see more examples. All right, so if I get a constant, first difference is constant, I know that it's a linear function. Okay, so let's write that down. So, first difference is constant, right? Means linear. Okay. Now, if I find that my first difference is constant, then I don't have to worry about the second difference. I can ignore that. Okay? Now, let's try to graph. So remember, again, on Monday, we learned, right? And we said we have to have the x and the y, and then we have to put them on the Cartesian plane, and then we have to find our, graph our line. So, what I have here, all the x's are positive, all the y's are positive, so I'm going to stick with my positive x and y. Okay? So this is my 0, 1, 2, 3, 4, and then 3, 6, so my first point is 0, 0. So I can put that right here at the origin. What's my second point? What is it? What's the x value for the second point? 1. What's the y value? 3. Okay? So my point is x, y. So the x is 1, the y is 3. So I can go x is 1, and then I go up to 3 for the y, and that would be my next point. Did anyone find a phone in this classroom? My next point is, what's my x value for the next point? The x value is 2, 6. 2, 6. So again, you're going to go to the x equals 2, the y equals 6, and then that will be your next point. Then 3, 3, 9, and 4, 12. Okay? And then if you join all these points together, you're going to see that they form a nice line. Okay? So from the graph, I can tell that it's linear because it's a straight line. We're good? Okay. So, if I'm looking at the equation, I'm looking at the degree. If I'm looking at the table of value, I have to do the first and second difference if needed. If I'm looking at the graph, I'm looking to see if it's a straight line. Okay? So, let's look at the next example. So I have the height of a falling marble is recorded and modeled by the equation. Y equals negative 5x plus 2. So if you look at that equation, what can you tell me? Linear or quadratic? Linear because degree is 1, exactly. Okay? So you see the degree here is 1, so we know it's linear because it's degree 1. It's important to be able to identify these. Okay? Now, let's do the table of values. Okay? Which means I'm going to take the equation and I'm going to enter the x values in the equation. So this part is already done. I just have to do the math now. Okay? So negative 5 times 0, 0 plus 2 is 2. Then I'm going to plug in 1 for x. So negative 5 times 1 plus 2. What do I get? I get too many different answers. I don't know. Negative 3. Negative 3. Okay. Eyes on me for a second. Negative 5 times 1. Negative 5. But math says I have to do that first. And then add 2. Negative 3. Okay. Negative 5 times 1. Negative 5. So I'm 5 below ground. And I went up 2. So I'm still 3 below ground. Second one, my x value is 2. So I replace the x with a 2. So I have negative 5 times 2. Negative 10. Plus 2.
Negative 8.
X. Carlos, can you pass? Okay. Next one. Negative 5 times 3. Negative 15 plus 2. Negative 13. And then negative 5 times 4. All right, so now I found the y values. Okay, my next job is to find the first difference. Okay, so I can tell if it's linear or not. Okay, so remember that your first difference is going to be like this. You're gonna start with the bottom y, and then you're gonna subtract the top one. So it's gonna be negative 3 take away 2. Okay, so negative 3 take away 2. That's going to give me negative 5.
Why do you do negative 2? It's not.
Because you're subtracting, right? Because you're doing the difference. Okay? So you're gonna do y2 minus y1. My y2 is negative 3, and I'm taking away 2 from it. Okay. Now, be careful. Can I have everyone's attention on the board for the next one, please? Thank you. So, I'm going to take negative 8, and I'm going to subtract negative 3. Okay, I'm going to write this on the side just so you see this. So I have negative 8, subtract negative 3. Okay. So if I'm taking negative 8 and I'm subtracting, you guys know why I'm subtracting, right?
The
Difference. And because the top one is a negative, negative and negative makes a Positive. So that's going to be the same thing as writing negative 8 plus 3. And this is where most of the mistakes happen. Okay? So negative 8 plus 3, that's negative 5. Then I have negative 13. Take away negative 8. So that's plus 8, which is negative 5. And then negative 18, take away negative 13, or plus 13. What am I doing here? Negative 18 plus 13 is negative 5. So what do you notice here with the first difference? What's your first difference for all of them? It's constant. They're all negative 5, right? So if you look at this, negative 5, negative 5, negative 5, negative 5. And because the first difference is constant, that means the 3 dots on top of each other, you guys know what that means? These 3 dots? Anyone? How do they represent it? Yeah. Therefore. Okay? So if I write 3 dots on top of each other, that means therefore. Yeah.
Do the 3 dots represent after?
Therefore. So instead of writing therefore, you can put 3 dots.
Therefore.
Yep. If you're solving. If you're solving, you put 0 for x. Anytime you're solving. All right, now let's graph this. So in this case, if I look at my x values and my y values, I have the y's are more than the negatives. Okay? So when I put my x and y axis, I have to be careful because if I put it like this, right, I'm wasting place because I want the negatives instead of the positive. So what I'm going to do here is I'm going to keep more room in the negative y values. Okay, so these are the x's and these are the y's. Okay, so you see I have more room in the negative. So I have 1, 2, 3, 4. I might not be able to fit all the points. So my first point is 0, 2. So you guys can see that my first point is at 0 and the y value is 2. My next point is at 1 what? 1 and negative 3. So 1, negative 3. Then 2, negative 8. So my negative 8 is here. 2 is here. So it's going to be about here. And then 3 and negative 13. So it's going to be about here. So now to scale, but you guys probably can do it better on a piece of paper. Okay, so again, it's a straight line.